Welcome, welcome. This is chapter 4, section 6, exponential and logarithmic equations. So these functions are one-to-one. So let's have a look at this. And then we can go down like that. Sometimes it goes up like that. So no matter which way we transform these, they're going to be one-to-one. So that means that there are some interesting properties. For example, if we can get two equations or two problems to the same base, then I know for sure that these guys are equal. And I will show you that here. So here, notice base 2, the exponents would have to be equal in order for these two things to be equal. Just like here, for this number 1, you have 5 to the 2x equals 5 to the 3x plus 2. So in order for these to be the same thing, I know that 2x has to equal 3x plus 2. So I am going to solve for x. So I'm going to get minus x equals 2, divide by a negative, so it's x equals negative 2. And then they'll be the same. Notice 2 times negative 2 is negative 4. 3 times negative 2 is negative 6, plus 2 is negative 4. They are indeed equal. You can also rewrite them. So here's the book's example. Notice how they rewrote the bases to be powers of 2. We're going to try that here. So that means we are going to have, well, I know that 25 is 5 squared. And properties of exponents says that I have to multiply these two. So I'm going to get 5 2x equals 5 6x plus 4. And I would solve the exponents. So that's minus 6. It's minus 4x equals 4 divided by negative 4, so it's going to equal negative 1. So that's what x equals here. Now we can also rewrite roots. So the square root is 5 to the half. So this is the property that we're using. So no matter what type of root we have, we can use it. So obviously now we can see that x equals half. Okay. So this is a nice little caveat. Not all of these are solvable, and we will see this here. Notice that 3 to the power of something will never give us a negative. If it is a positive 3 to the power of something, it will never give us a negative. Any positive number to a power will never give us negative. That just doesn't make sense. That's like saying 3 times 3 equals negative 9. Obviously, that would just not be true. So if you were to encounter anything similar to here, there is no solution. But then you would have to say why. Because. So we can sometimes solve these exponential equations using logarithms, especially if we cannot find a common base. This is your book's example. I will do number 5. So we have 2x equals 3x plus 1. Well, notice that I can't do anything because I can't make 3 have a common base of 2, and I can't make 2 have a common base of 3. So I'm going to take the log of both sides. And this allows me to do something really cool. I can now use the power property. Okay, and let me just expand on both sides. X, and I will distribute the log 3 plus log 3. So I'm going to just subtract to get all of my x's on one side. So it's x log 2 minus x log 3 equals log 3. I'm going to factor out my x. And this is where properties of exponents will definitely come in handy. So notice this subtraction, I'm going to use the quotient rule. So that gives me log 2 divided by 3. And then I can just divide that out. And notice when you divide, you would not flip the fraction inside of the log. That wouldn't be necessary. So what we get here is log 3 divided by log 2/3. Here, this is an interesting thing to note. Any bases that aren't the same, but that just have x as a single exponent, 0 will solve both of them, because 2 to the 0 equals 3 to the 0. What you get is 2 to the 0, anything to the 0 equals 1, and that's true. So if we have anything involving e, we have to use the natural logarithm. Oh, where'd we go? There we are. And we'll do this one as an example. 3e 0.5t equals 11. So I need to get just e by itself, the base completely by itself. So I'm going to divide by 3. So you're going to get e 0.5t equals 11 divided by 3. And I'm going to take ln of both sides. And what this cool trick allows us to do is, do you remember how ln is to the base e? And anytime you have the base, and then you have a base again, they cancel. So it just gives you 0.5t equals ln 11 over 3. So you will get t equals ln 11 over 3 divided by 0.5. And I'm not liking that decimal, so 0.5 is actually equal to half. And remember, when you divide by a fraction, you actually flip it and multiply. So you would get equal to 2 log 11 over 3. Okay. So notice this one started with a bunch of extra stuff, a 4 in front of the e and a 5. So we had to move that 5 over, divide out that 4, and then we proceed to solve like we usually do with ln. So we're going to do number 7. All right, there we go. So I'm going to do 3 equals, and I'm going to move that e to the 2t over. So it's 7e to the 2t minus e to the 2t. Well, notice that is equal to e to the 2t times 7 minus 1. So that's equal to 3 is equal to e to the 2t times 6. And now I can divide that 6 out, which gives me e to the 2t equals half. And I'm going to take ln. Okay. Again, these cancel, and I'm going to get 2t equals ln half. So that gives me t equals ln half divided by 2. Okay, this is a tricky one, solving it in quadratic form. So there would be multiple ways to do this. This one's simple enough. Okay, 2 ways to do this. First way, I'm going to rewrite it. E to the 2x minus e to the x minus 2 equals 0. And then, as up here, you would use the FOIL method. So that would give you e, one is positive, one is negative, e let me see, they will equal okay, so you have, they're going to equal negative 2 added together, they're going to equal negative 1. That would be negative 2 times 1 minus 2, so equals 0. This would be e to the x. If you can follow that, awesome. If not, have no fear, there's a better method. E to the 2x minus e to the x minus 2 equals 0. So if you much prefer looking at x's and this is a bit confusing, which quite honestly I don't like doing it this way, you can let u equal e to the x. So that notice what you have here is you have e to the 2x, which is equal to e to the x times 2, which is u squared, because this is just equal to u. Then that means that this whole thing is actually u squared minus u, because these are equal, minus 2 equals 0. And if it's much easier for you to see like this, you can solve it using quadratic formula if you wanted. Negative b, so that's 1. This is b, this is a, this is c. Plus or minus 1 minus 4 minus 2 divided by 2. It's going to equal 1 plus or minus 1 plus 8 over 2, which gives us 1 plus or minus, this is square root of 9, which is 3, divided by 2. So we are going to get 1 plus 3 is 4, divided by 2 is 2. And then we are going to get 1 minus 3 is minus 2, divided by 2 is minus 1. So that will give us u equals 2 and u equals -1. And remember, u is e to the x. So you just subtract over to make these 0, or add them in that case. So it becomes e to the x minus 2 times e to the x plus 1. It's whichever way you want to do it. They're the same thing. Some students just have a bit of an easier time when they have a substitution. Some don't. Personal preference. Okay. Let's see how long. All right. So now we would learn how to use the definition of a logarithm to solve these equations. So remember, this is the definition of a logarithm. Log b to the s equals c, which means bc equals s. So if we wanted to solve this one, well, I'm going to subtract over that 6. So it's going to give me ln x equals 4. Now I know ln is base e. So this is going to give me e to the 4 equals x. Oh, I guess they don't want you to, they just want you to get that far. All right. So our next one, we are going to try to get ln alone. So I'm going to have to divide everything by 2. And 10 divided by 2 is 5. So now I'm going to have e to the 5 equals x plus 1. So now I have to solve for x. So I just subtract 1. X is going to equal e to the 5 minus 1. Okay, this one we don't have to worry about. Yeah, we're still good on time. Okay, so the one-to-one property to solve logarithmic equations. So this says that if they have the same base and the only thing that is not equal are the insides, then the insides must be equal. I guess if that makes sense. So what that says here is we both have ln. So these insides must be equal. As you can see, they set them equal. We'll do one here. So this would be x squared equals 1. So that x equals plus 1 or x equals minus 1. So x is plus or minus 1. Okay, so they both work. You'll have to check if some give you actual answers. So I'd recommend plugging them back in. Okay, applied problems. All right. So how long will it take for 10% of a 1,000 gram supply of uranium-235 to decay? The decay formula is right here. So the initial amount they gave us of 1,000 grams, that's why you see this right here. ln 0.05 divided by t times t. Here we go. This is where they got this number because that's the half-life. T, this big one underneath. So that it looks like it will be given to you. So they pretty much just plugged everything in and they're going to have you solve it. We're not really going to have anything like this on the test, but this is a great example to try and solve things like you normally would. So notice I had to divide out my 1,000 to get my E completely alone. And then I applied ln to both sides, which allowed me to cancel out this E because that would just be 1 and, bring that exponent down, which is why I got to this step. And then from here, we just simply solve for T. And you will usually get something strange and you'll have to use your calculator. Okay. I will do a couple of exercises. So let's pick we will solve number 47. I'll do an example here. These are all mainly formulas. So ln of 7 plus ln of 2 minus 4x squared equals ln of 14. So these are plus. So what I can do is I can try to combine them. ln 7 times 2 minus 4x squared equals ln of 14. So ln of 14 minus 28x squared equals ln of 14. So now I know, because of the property of being 1 to 1, that all I have to do is solve. So that gives me minus, I subtract 14 from both sides, which leaves me with negative 28x squared equals 0. So x obviously equals 0 here. So that is how we would solve for x. If it did not equal 0, I would probably have had to use the quadratic formula to solve this, and then from there I would have put the individual numbers back in there, and if anything gave me a negative, then I would throw that value out. All right, this has been 4.6. I appreciate it. Thank you for watching, and I'll see you in the next one.